Dad, can you explain me a little bit about torsion?
So you want me to explain about torsion?
Torsion.
Okay, sure.
So Alip, you want to know about torsion, right? Alright. So torsion. Torsion usually happens in a shaft, either it a solid shaft or a hollow shaft. So there is a force that act on this shaft that act as a twisting force. This act as a twisting force in the shaft, and the force, this force is called torque. Okay, these two forces create a twisting effect to the shaft, and that's called a torsion. But Alip, before we go to the sample problem, we have to know the basic formula. So for the basic formula, we are Faris. Faris, come here. Can you help Alip to know the basic formula of the torsion?
Oh, this is for subject MOM, right?
Yes, MOM subject.
Okay. I think I can help you. Come on.
Okay, Alip, Idat, first of all, we need to know the formula. Just like Idat said, we need to know the formula. So the formula for the this topic, this torsion, is T, the torsion, and T C over J. So this is the basic formula. Okay, this basic formula, and there has two type of J. So we need to know whether the formula have the solid shaft or the hollow shaft. So I need to erase this first. So for the first, we must to know the for the solid shaft. Okay, the formula is for J is equal to 1 over 2 pi C power of 4. So this is for the solid shaft. Okay, for the second one is, for the hollow shaft. So it's same formula, and it's a little bit different. 1 over 2 pi and bracket C2 is for the outer diameter of the hollow shaft. Okay, and power of 4 and minus C1 power of 4 for the inner diameter. So you get it?
So what about this T and C?
Oh, T and C. This is the T is for the torque. Okay, for the torque, and C is for the radius, for the diameter of the shaft. Okay, the diameter, the radius. Sorry. Okay, the radius. Okay.
Okay, thank you.
Okay, welcome.
So may I know the simple application in the torsion?
Okay, the simple application for torsion, we can see Amin. I think Amin can show for you the real example of the application.
So I think Amin at the back of the house. So let me go find.
Okay, let's go. downstairs, I think.
So Amin at downstairs.
I think he's do some laundry, I think. Amin,
Amin? Oi.
where are you? I think he's outside already. There's Amin. Amin,
Amin.
this has some question to ask you about the torsion in MOM, right,
Yes.
guys?
Oh, meja guna subjek.
I think.
Guna subjek.
So, can you explain simple, basic about the torsion?
Buat torsion.
So, in application, you can show to us some example of this. Oh, okay. Oh,
About the question you all asked before, without we notice, when we washing our clothes, there will a torsion happen. Now I will show you how the torsion happen. Now we imagine this green thing is a shaft. Now we put a torque at the both end of this shaft and we twist it, sorry, and this is how torsion occur.
So, the deformation in torsion is called angle of twist. Angle of twist or symbol. In angle of twist, we can simply explain like this. In a shaft, this is called a normal line, which is the center line of the shaft. But when the torque is applied on the shaft, and it causes the shaft to twist, and the normal line will change into this new line, and the angle of the changing of the line is called angle of twist. So in angle of twist, the calculation to angle of twist can be simply put in this formula, which is angle of twist is equal to TL over JG. The angle of twist must be in radian, which is, if we have a angle of twist in degree, we have to change it to radian. T is the torque that applied into the shaft. L is the length of the shaft. J is the value that when you calculate that from the formula that been explained earlier, and G is the modulus electricity usually given in the question.
okay. So now we must know a little bit about the stress concentration. Okay. So if there have a change in our shaft, like this. This is D, a big D, and this is the small d, and this is the radius. So as we know, the formula before, that tau max is equal to TC over J, right? So if they have a change in this shaft, so we need we have the new formula for the change in the shaft. So tau max is equal to TC J times K. So what is K actually is you can find the K value in the graph. So it's right here. You can see in the graph the stress concentration factor for fillet in circular shaft. So D over D, the big D over the small d, so you can find the K value from this graph. So that's all for the stress concentration. Okay.
And now we go to sample question. From the question we get for the information for the hollow shaft. First, G is equal to 27 gigapascal. Given length is 1.25 meter. For the C1, that inner radius is 0.012 meter, and for the outer radius is 0.018. For the first question, we must find the torque for the given angle of twist is 4 degree. First we must convert the 4 degree to the radian, and we get 0.069. For the after we convert, we must insert all the information to the formula of the angle of twist, which is equal TL over JG. As the information given, we had know L is given, G is given. First we must find the J. As we know, the J formula is equal 1 over 2 pi times C24 minus C14 equal to J. After we insert all the number, we get 8.42 times 10 to the power of negative 8. Then after we get the J value, all we have to do is insert all the value according to the formula, and for the final answer for the torque value, we get 125 Newton.
Okay, I will explain about the application of torsion in aviation or aircraft. Okay, as we know, the torsion is like a shaft, and he has two torque which is at the different direction. Okay, as an example, the application of torsion we can see in the helicopter which is the shaft and the gear. The gear with example, the gear will turn at the clockwise direction. And the blade of the helicopter at the engine will turn anti-clockwise. Okay, and the other one is like the turboprop engine. This is the shaft. The turbine will rotate at the anti-clockwise, and the propeller will turn clockwise direction. And that's all the application of torsion in the aviation industry. Thank you.